All right, we're going to get you started on a little bit of velocity. Just a real quick uh, review of last year. We know that velocity is equal to distance divided by time. That's the basics. It's different than speed, which is distance divided by time as well, but velocity has a direction. And because it has a direction, what that automatically means is that it's not necessarily distance divided by time. It is the change in distance or displacement divided by the time would equal velocity. You can use your algebra to rearrange the equation. So we would have that change in distance over velocity would give you time, and velocity times time will give you distance. Easy speasy. Because it is a change in distance, you're going to have to go final distance minus initial distance divided by the change in time. Gives you velocity. Velocity's unit is normally meters per second. However, it can be any distance over any time. So you can have miles over hours, you can have feet over seconds, or whatever. So that's an important part. And usually in this unit, you like to also cover conversions. Conversions are that choo-choo track method that we talk about frequently of changing over units. So if you were given 5,280 feet, but we know that the problem is asking for miles per hour, we need to get it out of feet, put it into miles. All that is, you put the known unit down, and then you go to the conversion unit. We know that the relationship here between feet and miles is 5,280 feet. Whoops. 5,280 feet is in 1 mile. We'd multiply across the top, divide it by the bottom, giving us 1 mile. So hopefully this is all review for you guys. You shouldn't have any trouble. That leads you to your first assignment. Right off the bat, we can see that kilometers, so we know that 1610 meters are in 1 mile, and we also know that 1,000 meters are in a kilometer. Easy stuff. Here's some conversion practice right here. Let's see, anything else is particularly challenging. Here's an example of changing. Make sure you get your sign right, your direction right. Another example of making sure you get your direction right on 6. Average, okay, on an average speed problem, what you're going to have here is the total trip. So how long did it take? So what's the total time that it took divided by the total displacement or total distance? So you got to know that. 8's challenging. I imagine most of you are going to have trouble with 8, and then you're going to feel silly once I show you how to do it. All these look really manageable. They're just going to be a little bit more challenging than you're used to from last year. Like I said, these are the simple problems that we had last year, but I think it'll be challenging just because it's going to make you think a little bit more. It's completely doable. We will do them in class on Monday and Tuesday, so don't be too intimidated if you can't solve it on your own. And that's all. Can't wait to see you on Monday. Bye.